Hello everyone, and welcome. Today we're going to explore a very important separation technique called partition chromatography. Have you ever wondered how chemists can take a complex mixture, like ink or a plant extract, and separate it into all its individual parts? Partition chromatography is one of the most common ways they do it. The core idea behind this method is actually quite simple. It's all about how different substances in a mixture distribute themselves, or partition, between two different liquids that do not mix, much like oil and water. Let's break down how it works. In any chromatography setup, you have two main parts, the stationary phase and the mobile phase. In partition chromatography, the stationary phase is a thin layer of liquid that is held in place. This liquid is usually coated onto a solid support material, like tiny beads of silica gel or even a sheet of paper. The paper itself isn't the stationary phase, it's the water trapped within the paper's fibers that acts as the stationary liquid. The second part is the mobile phase. This is another liquid, or sometimes a gas, that moves through the system and carries the sample mixture with it. The key is that this mobile phase does not mix with the stationary phase liquid. So, how does the separation happen? We start by placing a small spot of our mixture onto the stationary phase. Then, we allow the mobile phase to flow over it. As the mobile phase moves, it tries to carry the mixture along. Here's where the magic happens. Each component in the mixture will have a different preference, or solubility, for the two liquids. Some components will be more soluble in the stationary phase liquid. These will spend more time stuck in the stationary phase and will therefore travel very slowly. Other components might be more soluble in the moving mobile phase. These will get swept along quickly and travel much further. This difference in speed is what causes the components to separate out into distinct bands or spots. A great example is paper chromatography, where you see the different colors in an ink pen separate as a solvent moves up the paper. Another powerful type is gas-liquid chromatography, where a gas is the mobile phase. Ultimately, partition chromatography separates substances based on their unique tendency to partition between a stationary liquid and a mobile liquid or gas, making it an incredibly versatile tool in science. Thank you so much for watching this explanation. If you found this video clear and helpful, please show your support by giving it a like, subscribing to the channel, and clicking the notification bell so you don't miss our future videos. Your support truly helps us continue creating educational content. We'll see you in the next one.